Hi, my name is Sophia Arina binti Nur Salihuddin. My student ID is 2025464408.
Hi, my name is Nur Shaira binti Abdullah. My student card is 2025465132.
Assalamualaikum and hi, my name is Nur Sumaya Humaira.
This is the first question. Okay, here the solution. First, you need to find the face value. After you find the face value, you will get 9622,000.61 and after that you need to find the different face value after 5 years with both face value, and you will get the 6022.61. So the conclusion is selling the cameras now and investing the 72,000 will grow to about 9622, which is higher than the 90,000 value after 5 years. Therefore, option A gives Zara a better financial return. So here the question 2, you guys can read by yourself first. For the question 2, you guys need to find the second deposit effect the growth of his saving. So for first thing, you guys need to find the face value for I choose 2 years. First I choose T, that is time, 2 years, and the other is 3 years. So I find the face value with the T, 2 years and 3 years. After that, after we find the face value, we should to find the second deposit within the two T years that we get. That is 2 years and 3 years. After that, you will get the second deposit. So the conclusion is the second deposit has a significant impact on Hanif's ability to reach 72,000 because it grows for a shorter period. The longer he waits to make the second deposit, the larger the amount he needs to deposit in order to his saving target.
Assalamualaikum and hi, my name is Nur Sumaya Humaira. I will continue by explaining question number 4. A. Determine her monthly payment. Explain the steps clearly. So how can we calculate the upfront payment? We can just simply multiply the apartment price, 780,000 ringgit, with 30% upfront payment, which equals to 234,000 ringgit. Secondly, we have to find the loan amount, since the question asked to calculate her monthly mortgage payment based on the loan amount. So we take the original price of the apartment, 780,000 ringgit, minus with the upfront payment, 234,000 ringgit, which we will get 546,000 ringgit. Right now, we want to find her monthly payment, and when we see monthly payment, it is a keyword for the topic of annuity. It is stated that there is 4.1% interest, which means the K will be 0.041. M equals to 12 because it is compounded monthly. T equals to 28 since it needs to be repaid over 28 years. I equals to K over M, which equals to 0.041 over 12. N equals to M times T, which 12 times 28 equals to 336. With these information, we can plug them into a formula. We want to find her monthly payment rate, which means we want to find the R. So the correct formula to use is A equals to R times 1 minus 1 plus I over I to the power of negative n. We use this formula because we don't have the future value of annuity, but we do have the present value. Now we can plug the values that we listed down into the formula. A, the present value is the loan amount, which is 546,000, equals R times with 1 minus 1 plus 0.041 over 12 over 0.041 over 12 to the power of negative 336. 546,000 equals R. Press the above calculation first on the calculator before pressing all the calculation. So 546,000 equals R times with 199.6413391. And to find R, divide 546,000 with 199.6413391. And the answer will be 2,734 ringgit 90 cents. And that is Alina's monthly payment. Question B. After completing the 180th payment, find the outstanding balance if she opts to settle the loan early. Alina has to make payments for 28 years, which she has a total of 336 payments. But the question asks us to find the outstanding balance after completing the 180th payment. So for this question, we need to change the value of n by subtracting 336 with 180, which equals to 156. Other values will remain the same, and now we can calculate the balance outstanding using the same formula. Since we have calculated the amount of R on the previous question, so we can just plug the value into the formula. R times with 1 minus 1 plus I over I to the power of negative n, 2,734.90 times with 1 minus 1 plus 0.041 over 12 over 0.041 over 12 to the power of negative 156. 2,734.90 times with, now it is safer to press the above calculation first on the calculator before pressing all the calculations. This is to avoid getting the wrong answer. which equals to 2,734.90 times with 120.768242. So the answer will be 330,289 ringgit 7 cents. That is the amount of the balance outstanding after completing 180th payment. Last question. Question C. If she fails to pay the first 5 monthly payments, find the amount she has to pay on the 6th payment in order to settle the outstanding amount. So basically, this question, we need to find the accumulated amount and the future value of the 5th payments that she fails to pay when the value of n equals to 6, because she has to pay on the 6th payment. So to settle the outstanding amount, we have to use a different formula, which is the formula of future value annuity. The formula of future value annuity is S equals R times 1 plus I to the power of n minus 1 over I. We just plug the same values from beginning into a new formula with changes in the value of n. 2,734.90 times with 1 plus 0.041 over 12 to the power of 6 minus 1 over 0.041 over 12, which equals 2,734.90 times with 0.020675903991 over 0.041 over 12. So now we just times 2,734.90 times with 6.051484,071. So the final answer will be 16,550 ringgit 20 cents.
Hi, so I will continue question 3, so you guys can read by yourself. So for question 3, we're using the formula S equals to P, bracket 1 plus I power of n. So we substitute all the values, so we get 12,240 equals to 10,000, 1 plus I power of n. So we divide both sides, so we get 1.224 equals to 1 plus k over 2 power of 7. So we take the 7 root, and then we get 1.0293. Habis pula. And then we minus by 1, and then we times by 2, and then we get k equals to 5.86%. So for question B, we get P equals to 12,240, T equals to 2, M equals to 2, R equals to 0.056 over 2, N equals to 2 times 2 equals to 4. So using the formula S equals to P 1 plus I power of n, we substitute all the values, and then we get S equals to 12,240, 1 plus 0.0293 power of 4, and then we get S equals to 12,240, 1.1225, and then we get the answer 13,739.40 cents ringgit. So for the question C, we use the new S, which is 13,739.40 cents, P 10,000. We're using the formula I equal to S minus P. So we get 13,739.40 cents minus 10,000, and then we get 3,739.40 cents ringgit. So the conclusion in investment growth is mainly influenced by the time period, interest rate, compounding frequency, initial capital, and additional deposits. Longer time, higher interest rates, and more frequent compounding significantly increase the accumulated value through the power of compound interest. Here's the question 5. You guys can read by yourself. So here's we get P equals to 30,000, K equals to 0.05, M equals to 12, N equals to 12T. So the down payment is 12%. So we get 3,600 by times the 30,000 times 0.12. I equals to 0.05. So the amount is 26,400 after minus the down payment. So with the interest charge 5%, we're using the formula annuity, which is A equals to R1 minus 1 plus I power of negative n over I. So we substitute all the value, which is 26,400 equals to 510, 1 minus 1 plus 0.05 over 12 power of negative 12t over 0.05 over 12. So we divide 26,400 over 510, we get 51.0647, and then we times by 0.05 over 12, and then we get 0.2157. So we change the place left to the right side, and then we get 1.0042 power of negative 12t equals to 1 minus 0.2157, and we're using the log formula, so negative 12 log 1.0042 equals to log 0.7843. So we get the answer t equals to 4.83 years. So the total repayment amount for S, when the interest is 5%, we're using the formula S equals to R1 plus I power of n minus 1 over I. So we substitute all the values, and then we get the final answer is 33,354 ringgit. So when the interest is 10%, we're still using the annuity formula, so which is A equals to R1 minus 1 plus I power of negative n over I. So we substitute all the value but change the nominal rate to 0.1, and then we're still using the same way, and then we get the time, which is 5.69 years. So the total repayment amount for interest 10%, we're using the formula S equals to R1 plus I power of n minus 1 over I. We substitute all the values, and then we change the times value to 5.69 years, and then we calculate, and then we get the final answer, which is 46,652.76 cents ringgit. To conclude, when the interest rate increase, Farid ends up paying much more in the total because more of each monthly payment goes to interest instead of the principal. This causes the loan to take longer to finish and makes the overall repayment amount significantly higher. Thank you.